Hey everyone, and welcome back to The Explainer. Today, we're diving straight into the world of an absolute giant, the Irumpakam tree, or as it's commonly known, the Ceylon ironwood. From its towering presence in our ancient forests to some really surprising modern engineering applications and even hidden healing properties, this tree is, well, it's absolutely going to blow your mind.
Okay, let's take a quick look at our roadmap for today. We've got 5 stops. First, the giant of the forest, then the strength of ironwood. After that, we'll look at ancient healing and Ayurveda, followed by the struggle for survival, and finally, preserving our forest heritage. Let's get to it.
Section 1. The Giant of the Forest. You know, when you actually encounter one of these ancient, native trees in the wild, the very first thing that hits you is just the sheer scale of the thing.
Scientifically, we're talking about Hopea parviflora. It's a tall, evergreen tree from the Dipterocarpaceae family, and it's proudly native to the warm, humid, and just insanely biodiverse regions of the Western Ghats in South India, as well as over in Sri Lanka. It really thrives in these moist, tropical environments where it basically dominates the natural forest structure.
It is just incredibly impressive. You've got this strong, straight, heavily buttressed trunk that stretches way up into a broad crown. In natural forests, these mature trees stand as massive, majestic landmarks right in the middle of the canopy, literally anchoring the soil with their deep roots. And that highly specialized nature extends right down to its leaves. They're simple, leathery, and have this gorgeous glossy green finish. But they do something absolutely vital for the ecosystem. They create these intricate patterns of light and shade on the forest floor, essentially acting as a giant umbrella. That maintains a very specific microclimate underneath the tree that countless other organisms totally rely on to survive.
Moving on to Section 2, the strength of ironwood. So, we're shifting from the peaceful forest canopy to some hardcore physical properties. And trust me, there is a very good reason the word iron is in its name.
Which brings us to a really fascinating question, especially if you're into structural engineering. Can traditional, heavy timber actually compete with modern structural steel? I mean, we usually think of steel and concrete as the ultimate building materials, right? But modern engineering is giving this ancient wood a pretty massive upgrade.
Recent engineering data shows us something incredible. Researchers took wooden specimens of Hopea parviflora and wrapped them in glass fiber reinforced polymer, or GFRP. Just by applying a 2-strip wrap, the compressive strength shot up by 27%. And with a 3-strip wrap, it jumped 33.4%. Now, another wood, Pterocarpus indicus, did see a higher percentage increase in compression, but our Irumpakam tree boasted the absolute highest baseline tensile strength. Basically, this polymer wrapping delays failure and drastically increases load capacity, without needing super heavy steel plates.
So, this combination of natural density, its interlocked grains, and how well it takes to modern composite wrapping makes Irumpakam an absolute powerhouse for heavy civil engineering. Historically, and even today, it's highly sought after for railway sleepers, shipbuilding, and traditional South Indian Madras terrace roofing. It is incredibly heavy, super hard, and just remarkably durable.
All right, Section 3, Ancient Healing and Ayurveda. Because the story completely flips here. We're pivoting from brute mechanical strength to some deeply soothing, hidden medicinal properties.
It's such a crazy contrast. On one hand, you've got this heavy construction timber holding up bridges and ships. On the other hand, early 16th century Malayalam folk texts refer to this exact same tree as Velakali, a powerful yet delicate healing agent. So how on earth is a timber this tough also a medicine?
Well, the secret is all in the bark. Phytochemical analyses show an absolute treasure trove of active compounds. You've got gallic acid, which is a fantastic anti-inflammatory. There's ellagic acid to fight off free radicals. Up to 12% tannins, which are brilliant for promoting wound contraction. Plus, it's packed with flavonoids for anti-allergic action. Essentially, these compounds act as ironclad defenders against oxidative stress, actively blocking pro-inflammatory pathways in the body like COX-2. So, how does this translate into traditional Ayurvedic practice? First, harvesters sustainably prune the small branches right after the monsoon season. Then, they powder the bark and boil it in water. This creates a really potent yellowish-brown decoction that's traditionally used for joint pain. Or you can take that fine powder and mix it with honey or sesame oil to make a topical paste for soothing skin rashes and healing minor wounds.
And the wild part is, modern science is totally backing this up.
Recent clinical pharmacology studies showed a staggering 75% faster re-epithelialization, which is basically the skin healing over a wound, when using just a 5% Irumpakam bark extract cream compared to a placebo. Modern dermatology is literally just catching up to centuries of tribal knowledge.
Section 4. The struggle for survival. This incredible utility brings us to a pretty harsh reality. We need to look back at the forest to understand a heartbreaking paradox. This ironwood might seem invincible when we use it, but it is extremely fragile in the wild.
To get why, we need to talk about an ecological concept called the regeneration niche. This is that highly competitive, really early life stage of a tree, where seedlings and saplings have to fight intensely for limited sunlight, water, and nutrients just to make it to adulthood. Because of this struggle, a forest can look beautifully green and healthy from the outside, but underneath, it might actually be completely failing to replace its aging giants.
A deeply concerning study from the Kodiyar forest in the Western Ghats highlights a severe ecological bottleneck here. While the survival rate of the adult Irumpakam trees is actually quite high because they're huge and established, the juvenile tree mortality rate is extremely high. Young saplings are dying off way too fast due to intense competition and environmental stress on the forest floor.
This leads to what ecologists are calling the Kodiyar paradox. Over a 3-year study in this specific tropical forest, despite a gorgeous, dense canopy of adult Hopea parviflora trees, researchers found absolutely zero juvenile saplings. None. Let that sink in for a second. The species is facing a massive natural regeneration crisis because it didn't produce a single surviving offspring in that study zone.
Which brings us directly to our final segment, Section 5, Preserving Our Forest Heritage. We really need to talk about ecological awareness and what this means for our future.
Consider the gravity of this quote. Protecting mature Irumpakam trees means protecting not just one species, but countless organisms and ecological relationships associated with the forest. Losing just one mature ironwood tree sends a ripple effect through the entire ecosystem, disrupting everything from the tiny insects pollinating its flowers